So it says one the product AB has been added, but we can recover from it. For example, 2 times 4 x. How do you recover to um mm, yeah, wait, let me think another one. Let me think. Like 56. There are few ways to break down it. But LY, even LY, LU conversation is like just one way to like decompose it. Maybe not from these conversations. Yeah, makes sense. Hello, testing. Very good evening to all. First time I go to class, use good evening. Um, so before we start, I heard that you guys have some question, right? Um, so some of you asked me, what's the difference between lecture notes and Blackboard notes? Correct? I upload two versions there. Okay. So as the name suggested, so Blackboard notes means whatever I wrote on the spot on the day. Okay, I upload that version. And lecture note is the one that I organize already. Okay, maybe I miss something or I say something wrong in the class, then I will make changes in the lecture notes. So in principle, lecture notes should be more complete than the Blackboard notes. So why if in that case, why do I upload the Blackboard notes? Why? Seems like double work, huh? Yeah, for the record. Okay, so in case you want to recall what I said last time, you can go to the Blackboard notes. Okay or not? And also, some of you said that, hey, your lecture notes seems quite different from the Blackboard notes. Is it different or not? Have you guys seen? Huh? Sorry? Sorry? What did you say? Got some difference, okay? Because I fill in some of the details there. Or in the class, I cannot, how to say, due to time constraint, I cannot spell everything out. But in the class, so in principle, what I do in the class is I have to tell you the concept or the technique such that you should be able to work the details out yourself. Does it make sense? But in case, you say, hey, really different, or I don't understand this part. So what do? I really don't understand this part here. What do? Ask me lah. Ask me lah, okay? Okay? Just ask me. Just ask me. Okay? Don't say that what very hard or what. It's nothing like that. I can tell you the answer one. You just ask me. Okay? Just come and approach me. So the other way is come to this one. Okay, Math Health Center. There's a master student here. Okay, so some of the master have taken like pure maths courses here, so they should be able to help also sometimes. Or come to my office hour. Okay, come to my office hour just now 2 to 4 or tomorrow 3 to 5. Okay, come to my office hour. Okay, so don't worry, there's not just one of me. There's other students who taken this course before. Okay, taken courses with me before, so they know my pattern also. Does it make sense? Okay or not? So just get help, get help. And also the assignment, if you notice, maybe it will be harder than what you think. Okay. I want to say harder than what you think. I want to say like that. Because assignment is not homework. I want to say like this. It's not homework. It's not like I teach you something, you simply figure it, you can figure it out. Unless you are genius. Okay or not? My assignment, okay, the how I set my assignment, I set it such that you understand the concept and then you can write the answer out. Okay, it's not you just copy and paste, 看差不多一样就是一样 lah. It's impossible like that. Okay, because I won't repeat my question. Does it make sense or not? Okay. Although the question look maybe completely different. I never see this before. But I can assure you the answer or the solution used must be something you learned before. You just need to know how to recall these concepts. Okay, this is what you need to learn in this class. Okay, I'm not sure other lecturer can do this or not, but in my class you can. Does it make sense? Is it clear? Is it clear? Okay. So if you think hard, okay, spend time, find resources, or ask me. Ask friend. Must ask friend, discuss with your friend. Okay. But just one thing you need to remember, don't copy answer, that's all. Okay, write in your own word, that's all. Okay or not? Can you believe or not? Even same answer can write differently. Do you know? You believe? How are you so sure? You believe? Okay. For example, everyone here shower or not? Do you guys take shower? 冲凉吗？冲不冲凉？ Take shower, right? But 全部人都洗头先吗？ Does everyone take the same procedure to shower? No, right? Different people take different procedure. Okay, some wash hand first, maybe. I don't know. Maybe some wash shoulder first. Who knows? Right. So same things can be done differently. Okay? Does it make sense? Okay, 没有唯一的答案呢，在这个班。Okay? As long as what? As long as it makes sense. Okay, makes sense. It's the thing you need to learn here. Make sense. Okay, 怎么找到一个怎么说有道理的答案 Okay, makes sense. Answer that makes sense. This is what you need to learn in this class. This is difficult. Okay, I acknowledge this is difficult, but we have to learn in this class. Okay, otherwise, this degree is completely useless because in real life you won't learn, you won't use group one. Okay, you won't see set, you won't see element. But once you see things as set and element, then you are already up a level. Okay. Okay, another thing I need to get some help from you. Because I joined the do you know our school have a orchestra club? You know or not? Okay, I'm the teacher advisor for them, but I also joining their concert this November. So that this November they have a concert, end of November. So I have to join their weekly practice. But unfortunately, their weekly practice crash with your class now. Okay, they practice from 7 to 10. So is it possible that we change the time of this class for 2 months? Yes, yes. I also yes. I also don't like this time actually. But how about the rest? Let me list some choices for you. Let me list some choices for you. List some choices for you. Let's pick some choices, okay? You cannot see Let me give you some choices. Let me see. So Monday 7 to 9 p.m. Wait. Still got more. Tuesday 9 to 11 a.m. Okay. Thursday 9 to 11 a.m. Friday 3 to 5 p.m. Friday cannot. Friday cannot. Okay. What else? Other timing? Tuesday seems okay. Try see. Yeah. Tuesday. Okay, Thursday too many class. But to be safe, maybe we don't have classroom. Can I pick another backup time or not? Monday. Monday. Change another night. Also no choice already. Monday. Worst case Monday, second choice. Okay, first choice, second choice. Okay, hopefully we also get Tuesday. Okay. Yeah. I think this will last for 2 months until November 30. Yeah. November 30, their concert. But I need to apply first. After confirm, only let you know. If not, then we will continue with this time. Okay or not? If this 2 time okay, right? I also will use this 2 time as your holiday replacement. No? Is it okay or not? Because we have 2 holiday we need to replace. Actually, our class is behind schedule about 1 week. So a bit hard to arrange our assignment now. So I think I already come up with the assignment. So the deadline should be next Wednesday, right? But I write there is extendable to Friday. Okay, so if you can finish before Wednesday, if cannot, then you can hand in Friday. So how many times you can meet me like 3 times office hour before submit maximum, right? Okay, so make sure you get help. Make sure you get help. And then you have like 1 week or more than 1 week to do it. Okay or not? Does it make sense? Okay, ma. Okay, okay, so everyone happy? These 2 time, first choice, second choice. Okay, everyone can make it. Okay, then I will try and apply. So don't want Thursday. Three class. Okay. 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 All right. Okay. So this is admin stuff. So any other question for the lecture? Did you do okay? Okay. Another thing people bring out is I upload a lot of resources for you. Okay, I upload a lot of resources for you. Should I go through some of them with you? Do you know how to use them or not? Let's see. Okay, some of them I mentioned before, but some of them I didn't do because too many things to share last time. Okay, in particular I upload these 2 years lecture note by Dulip. Why do I you guys know Dulip? No, Dulip. That he taught you guys before, is it? Calculus 1, I think he taught everyone calculus. Okay. So why I upload his lecture note, because his lecture note got a lot of examples. Okay, if I didn't cover any example, you can go to his note. Okay. Past year tutorial should be okay also. Okay, so these these are reference book other than textbook. Okay, if you cannot understand textbook, then you can go to the other reference book. And if I post a solution manual to this book, that's mean this book have a nice exercise you can try other than the exercise I gave you. Extra exercise lah, okay, to help you if you are a very hardworking pupil. You can go and do it. Or read, at least read. At least read. Answer 已经送给你了。Read. Okay. Is it okay? Yeah. So R13, if you notice the book R13 we use, there's no solution manual. So that's why we choose to type it up. Okay, we type it up. And we type out those we need. Okay, those I listed. We type it out. Okay. So if anyone here is very good in LaTeX, if you want, you can help me to type out my lecture notes. Also can. Maybe easier to read. Extra credit. Extra credit is you will learn more. You will understand more. Because last class also I got a master student help me to type out my general topology. So he find my typo and then he asked me, hey, this one should be right like this one. No. Then I tell him he understand it wrong. Then he learn like that. And he got A in my class. Very solid A. Very solid A. Okay. Another thing, I think people like to ask 老师你的及格率是多少？喜欢 fail 人吗？其实我不是很喜欢 fail 人，但是我会 fail 不努力的人。That's all. So in my class, you need to show commitment. You need to show improvement. These two. Okay. You are weak is okay, but you have to improve. Okay or not? But if 你要拿 A, you need to work really, really hard. Okay? Okay or not? Okay 吗？明白哈？很直白嘛，对吗？很直白哈。Okay. So I won't like to fail people, but you need to work hard in my class. Okay, if 你摆烂， then I cannot help you. Okay, if you are being like how to say 摆烂giving up giving up. Okay, if you try giving up, complain, then I cannot help you. Okay or not? Okay, if you try to work hard, come approach me, I can help you one. 很多人都是这样过了，他 fail 我第一个课 ，cause 我已经在这里教2个 Seng 了嘛。第一课他不认识我，他以为可以混过去，不可能，在我班 fail。第二次又来你觉得他 fail 还是 pass？ 你觉得他 fail？ 你很坏耶你。No, in second time he came again. He didn't fail. He passed. He know my pattern. He work hard. 哎呀，老师，我很辛苦天天读你的东西Yeah, that's right. I want you to be hardworking. That's all. 过了，他第二次就过了。OK，so far 我还没有连 fail 2个人，连 fail 一个人2个 Seng 我还没有做这件事情，还没有做到。所以我希望大家 OK 努力可以 pass 的。OK，pass 很简单的。为什么很简单你不算吗？你们是数学家耶，你们算一算嘛，有几分是握在你手上的？算一下 ，How many points is on your hand? Tell me, based on this assessment, how many points on your hand? 40. Assignment is you do one. Correct or not? You can check answer one. Correct or not? You can find resource one. Why not get the full 40 marks? 考试考10分都 pass 了啦，对吗？是不是很简单的吗？
那如果你 assignment 又不做，assignment 乱做，我怎么给你分？你考试又不会，你明白吗？你明白吗？assignment 啊，very important 啊。I look，我跟你讲啊，我以前上课的时候就是这样，assignment 我全部拿100了，拿100了。不是我厉害，真的，我不是很厉害的，我不很厉害。我也是问同学，问 senior，然后说 ask senior ask lecturer，真的就我一个人坐在老师的办公室里面吧，office hour，我问他，天天问，每个礼拜问，反正他讲我不明白嘛，我不是去问他咯，对不对？search 哦，search internet 哦，resources 哦，OK or not? This 40 marks is in your hand, you know. You can control one, okay? The other 60 mark you cannot because it's what I gave you. But let me assure you, whatever I test in the class is whatever I emphasize in class. So you need to listen carefully in class. Whatever I say you don't understand, you must ask. Okay or not? 我会很注意我在班上教的东西。OK，可能这一班跟上一个班注重的东西又不一样了，所以你只有这个班，只有这个小时是 special for 你的，customize 给你的，你明白吗？OK 了，所以我不怕学生不来听课的，不来听课他就是他自己亏本，他自己 fail 了，我不用理他的，你明白吗？是学生自己要来上课的，Does it make sense？OK 嘛？因为啊，我老师跟你讲为什么可以做到这件事情，Why I can do this? Because there's too many to share，太多东西我要教你们了，所以我们每个人就2个小时，我们不可能教到一模一样的，而且跟着水准跑。OK 啊 ，It must be customized。OK，very flexible 啊，我 very flexible，不是说我今天一定要跑完这个我就跑完这个。It's not like I need to run some routine stuff. Okay, we will be flexible. Okay, flexible to you. So make sure in class, ask, discuss, okay, understand. That's all what you need to do in this class. Okay, does it make sense? Okay or not? Okay, 合理吗？对啊，明白啊。All right. So last time we only have one single definition introduced last time. Do you remember? What's the thing we introduced last time? There's only one thing. Huh? What definition? Okay. Pretty you remember banana. Good, good, good. Okay, banana is a very good example. You need to remember for your whole life. Okay. Okay. So come serious. Okay. So actually we introduced the definition of a set. Okay, we introduced the definition of a set. So what's a set? Collection of elements. Okay, collection of elements. Okay, so there are something that you put together. Okay, become a set. So for this definition, please keep in your mind because in your midterm, right, you are allowed to bring a cheat sheet. Okay, what can you put in the cheat sheet? Literally everything. But suggest you to put all the theorems and definition. Okay. Yeah. So you need to be very familiar with this definition. Okay. So let's recall then. So let's recall definition. A set. Hey, sorry. And let's recall. So a set is a collection elements. Okay. So in mathematics, when we talk about definition, there are really only two kinds only. Nouns or adjective. 知道什么意思吗？名词或者形容词。Okay. Either I want to define an object or I define a adjective for this object. Okay. 所以意思说什么？意思说什么？ There are two kinds. There are two kinds. So you need to be careful. So here is nouns or adjective. Okay, so 这个是个 object. So you should think maybe in future we have adjective. Can you think of any adjective for set or not? I think you learned discrete math already, right? Any adjective you can put on set? Good. Finite set. What finite set mean? Countable, huh? Then right? What else? 会给人打哦，这个。So finite set means what? The number of elements inside the set is finite. Okay. So I mean, if you don't like the finite because we use finite again, so meaning what? The number of the element in the set is, for example, is a natural number. For example, I don't know, is a natural number. 1、2、3、4，对不对？ Right. So this is nouns. So next, we want to prove something. Okay. Well, straight away prove something. This is a very important statement which says that there is exactly one set with no elements. Okay. So actually, this sentence here, there are actually two things to prove here. Okay. I'm not sure you are exposed to this idea yet. So it says there is. There is means what? There exists. Okay. So if you want to prove there exists, what do you need to do? What do you need to do? Find me one. Okay. For example, there is a natural number. How to prove? Find one. Which one? One. Correct, no? One is a natural number. Okay, one exists. But here there's one special thing. Exactly one. No others. Exactly one. So meaning what? This set is unique. Okay, so there exists a unique. So this statement here comprised of two property: uniqueness. Uniqueness and existence. Okay, so in this course, frequently you will see this. Exist or not? Okay, a map, or exist or not a solution. Okay, if exist, unique or not, got other solution or not. Okay, uniqueness. Two things. Okay, frequently throughout these courses, we will have proposition. Okay, concerning uniqueness and existence. Okay, I will share you more idea later about this existence and uniqueness. Okay, so I said this is a proposition, right? So we should prove it. Okay, which one should we go first? Existence or uniqueness? Existence. Okay, let's go with existence first. Anyone would do, but we can choose existence first. So why does it exist? Okay, there's only really one definition you can think about here. Nothing you can think about already. Okay, it's talking about set. Why does it exist? Why this definition allow this kind of set? Yeah, I give you 1 minute, try and think about it. Why you can only have this definition to think about, nothing else. So the answer must come from here. Okay, anyone have any idea or not? Elements means what? Empty. So from the existence, from the definition of set, what can we do? We actually can take a empty collection of elements. Okay. So the definition there is never mention that the elements have to be non-empty. Have to be non-empty. It's just something. Nothing also something. If you come across a backwardsly true in discrete math, you know what is backwardsly true?
Yeah, if P then Q. So what does it mean by the statement is vigorously true? 后面一定对啊，我忘记了。错的比较重要哎。If P implies Q, what is the logical true and false? What's the table? Truth table. What's the truth table for P implies Q? If P false, what happened? Huh? Okay, if P false, Q false implies what? True. If P false, Q true, Q true. So if P false, anything true lah. I don't care Q already. Does it make sense? Very important, this one. Vigorously true. Okay? If P false, 这个叫什么啊？谬理啊，可以证明一切，听得懂吗？听得懂吗？谬理可以证明一切，错的东西 can imply anything. Anything wrong can imply everything. So in mathematics, we don't want to talk about false statement. 没有用 false 肯定 imply 全部东西。Okay or not? So that's why in mathematics we focus on proving true statement. Okay, if it's false, can imply anything. Okay, imply anything is still true. Does it make sense? Okay. Okay. Right. So we can take empty collection of elements. So next, uniqueness. Okay. Have you guys seen any uniqueness proof before? Yes or no? Yes. How? Can you share? Linear algebra. Okay. How? How did you guys do uniqueness proof? Yeah, good, 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 very good, very good. Okay, so what do you do in uniqueness? You want to prove there's only one thing, right? Okay, like contradiction. Suppose there's another one with the same property. Okay, and then in the end, we show that they are the same. Okay, so for now, we want to show that there are only one set with no elements, right? Suppose what? Suppose we have, there are two. Okay, suppose there are two sets, A, B, with no element. Okay, suppose there are two of them. And then we want to show that what? What do we want to show? We want to show that A equals B. Okay. So a very good exercise when you guys write proof, put your goal first. 把你的目的地写出来，才知道去哪里。If not, otherwise you will get lost. Okay? Every single time, write out what you want to show first. Yeah, I want to show. Yes, thank you. Yeah, so this is a shorthand for want to show, by the way. I'll put a lot of want to show. So I want to show A equals B. What kind of equality is here? Last time I remind you, right? Need to be sensitive to this equality sign. What kind of equality here? Equal as what? Huh? Who say? Equal as what? Same one. Yeah, same set. Equal as set. Okay. So how do you show equality as set? What's the definition? When two sets are equal? Hmm? If and only if? What? I heard someone mumbling. Huh? Okay, what is in here? In here is very important. A is a subset of B and B is a subset of A. Because in sometimes we'll say an element is in the set. So you need to differentiate between these two. It's different. Okay. So you need to show that A is a subset of B and B is a subset of A. But what does it mean by A to be a subset of B? So you need to show two things, right? So how to prove? For example, how to show A is a subset of B? What's this? What's the definition of subset? Definition. Discrete math, I think. A subset means.
You guys know how to draw Venn diagram or not? Okay, so how to draw this Venn diagram first? Sorry. Okay, any shape. So then how I put A, B together? Okay, A inside B or B inside A. So if I talk about A inside B, meaning A is a subset of B. So maybe something like this. But how do you show it? This is just diagram, Venn diagram. This means what? Everything in A is in B. Okay, so we need to prove that everything in A is in, implies that X is in B. Okay, so this is what we need to get in. Does it make sense or not? Okay, so we go from showing A equal to B to show that this element implication. Okay, good. So suppose S is in A. Okay, so this is what we want to do. And then we want to show that X is in B. Okay, or in other words, want to show what? For every X in A, so every X in A, X in A implies X in B. Okay, so we want to show that this statement is true. Statement true or not? Is this statement true? So, I mean, we start from here, right? What do we know about this statement? What's the thing you know inside here? What is the thing we assume? X in A. But do you know something about A or not? You sure you don't know? What's the first line we wrote? Empty. I haven't introduced empty set. Let's not break this secret first. Okay. A is a set with no element. Okay. But I say X is in A. Possible or not? No, nothing is in there. So meaning what? Meaning this statement here is what? False. Just now we discussed what? False will implies anything. Not false implies true. False implies anything. False can imply false. False can imply true. Everything is still true. Okay, because we want to get the whole statement true, right? We want to prove that this statement is true. Okay, but we know that P is always false. But false can imply everything. Okay, so since A has no element, so there is no X in A. Okay, hence we have A as a subset of B is vacuously true. Okay, vacuously true. Nothing to check. Yeah, no. Does it make sense? Any question? Yeah. Yeah. Okay. So the other direction you need to prove also, but I just left as exercise. Okay. So try and show B in a subset of A. So can you imagine it go through the same process or not? Because B is the same, it has no element in there. Okay, so basically you just replace the proof of A by B. Okay, and then B by A. Okay. Try and write it out as an exercise. Okay, very important. Uniqueness exercise. Okay, so in this case, we will say that by similar argument, okay, by similar argument, we get B as a subset of A. Okay, so we prove it. Okay, so from this proposition here, we will define the
empty set, okay, the one that you know very well. Okay, from here, we will define the empty set. So the empty set, we will draw 0 and then slash it out. It's a set with no element. Not just a set. From what we prove, we can say that it is the set. Okay, it is the only set that has no element, the unique one. If there's one exists, it is the only one. Okay, no. So we can say the empty set. There's no empty set number 2, number 3, number 4. Only one empty set. Okay, they are the same. Understand from what we have shown? Any question? Yes. QED, QED. Oh, QED, what is QED? Okay. Okay, very good, very good. So this QED is a Latin word. So whenever we finish the proof, we will put a QED. So the proof is done. Okay, if you want to find a full word for this QED, you can try and search Google. Okay, it's a Latin word. Okay, QED. Okay, it tells you that our proof done already, finished already. No more already. Okay. Make sense, huh? Okay, good. Very good. Okay, I want you to think about so we talk about uniqueness and existence. But does both of them have to come together? Why not? It can exist, but no need to be the only one. Give me an example. Exist but not unique. Yeah, give me an example. iPhone 16 iPhone 手机 okay, why is it not unique? Then unique or not unique then? Everyone is the same. Okay, so you mean iPhone, there's just an iPhone, but not all people have the same iPhone, because you might have iPhone 11, iPhone 12, iPhone 13, iPhone 14, iPhone 15, is it? Correct. But still an iPhone. Okay. 乱了 Okay. 你就好。没有啦，没有啦，开玩笑，开玩笑啊，真的有差别，因为它的 camera upgrade 了。喂，这么好让我变成 Team Cook 在这边啊。OK，Yeah，so 这样 agree 嘛？它不 unique，agree 吗？Okay, one example, change example. What is something that exists but not unique? Change example. Right, change example. Change example. What is something exists but not unique? 没有这样难吧？Turn to ODE, Does everyone agree or not? Exists but not unique. Agree Solution to ODE. 没有人好像很 agree. 来找一个大家 agree 的。What's something that exists but not unique? Natural number Okay, natural number. Okay, 可以 natural number. 哎，可以这样讲吗？I don't think so. I cannot. I don't think so, because you want to talk about natural number as a whole. We want to talk about as a single object. Let's think. What's a good example here? What's the thing that exists but not unique? 很纠结。Okay. Got or not? Got or not? Got one, a lot. A lot one. Exists but not unique. What's a good example? How about I say car lah? Okay, maybe got different type of car. Okay, no. Did you see different car on the road? Yeah, right. Okay, different car. Okay. So what else? Could it be unique but doesn't exist? 不存在，但是又很特别哦。神哈 Okay, I agree. Son, I agree. How about this one? Phoenix. Everyone know about Phoenix? 凤凰 OK，好像没有，可以去搜一下故事，好像是没有两只，就一只吧。OK，but in real life you don't have, right? Just people make it up. How about what other cases? No unique or and not exist people still talk about it. 哇，人真的是够特别，没有的东西也可以讨论啊。Not exist and also not unique. I think if you watch movie, you know, there's one example in my mind. Marvel movie. I don't know. I think of one example. Thanos. Right, in the multiverse. 啊，存在咩？所以我才说嘛，有些东西就存在头脑，但不是在现实中看到。OK，exist me，我是真的可以挖给你的，就是摆在你面前的。就说他在平行世界嘛，有吗？有在平行世界吗？我不懂哦，应该有吧？平行世界有啊，你去看一下，去看一下，去看一下，也。最后一集的 Ant-Man 啊，如果我没有记错的话，我看到很多个 Thanos 的出现。Ant-Man，不知道是 是 Ant-Man 应该忘记了，但你可以去看有。OK，yeah，so all possibility there are example that people interested. OK，for out of any reason 人的想象力是无穷的。OK，所以不要局限你自己。OK 了。Okay, what time is it? 7:43. Okay, let's go a bit further. Let's go a bit further. So you can keep thinking about this later, later, not now, later. Later, you can go back, think again. Okay, about these uniqueness and existence. Okay, before we take a break for this hour, let's go a bit further. So let's discuss law of composition. So we have a set already. Okay, inside this set could be something, could be nothing. Okay, could be something, could be nothing. If there's something there, we want to try and put them together, combine them together. See if we are still living inside the set or not. Okay, or we live outside the set. So how to combine them together? This is what we call a law of composition. Okay, law of composition. Composition 知道吗? Do you know what is compose mean? 放在一起 Okay. Law 呢? Some rules. Okay, rules to put things together. Okay, law of compositions. So we will typically write LOC. Okay, law of composition. So this law of composition is a noun or adjective? Nouns. So this law of composition is defined on a set. Okay, so you need to tell me what set whenever you tell me a law of composition. Why? Because I will define it as a function. Okay. So now we reach to the rim of function. Function of what? Okay. This function takes two elements. Okay. It's a function of two variables. Okay. Let's call it star. From x cross x back to x. Okay. So what does this mean? I have a set. Okay. I take two elements, put them together. And then it is still an element inside the original set again. This is what this means. Can everyone get it? Okay, good. So I need to be precise a bit. I need to tell you what is S cross S. You know how to put 2 cross 4, right? But what is X cross X? So X cross X is a product set. Good. Is the product set. But what does it mean by product set? Okay. So to tell you about a set, I need to tell you how the elements looks like. I just need to tell you how the elements looks like. Okay. So how does this element looks like here? They are tuples. Okay, they are tuples. So they are pairs. So we write bracket X and Y such that X and Y, both of them is in S. Okay. So if you can imagine, I also can change this definition of let's say X cross Y. Okay, then it will be some element from X, some element from Y. Okay. Okay, don't confuse with the XY I put here, little XY. What I'm talking about is some random set, two set. If you like, I can put like U and V, U cross V, meaning what? They are all pairs XY such that X is in U, Y is in V. Okay, for example. Okay, so this is a law of composition. And right, so sometimes in the textbook, what do you see? Let me put here, so let me put as a remark. Sometimes in the textbook, they will say that LOC is called a binary operator. Okay, why is it binary operator? Because it takes in two things, binary. Okay. Then in this case, we will write, we write the set X with X LOC as S comma star. Okay, sometimes we write like this. If I need to tell you what is the LOC I put in the set, okay, X comma star, okay, comma the LOC. Right. So before going to example, let's discuss more. So there are a few types of LOC we are interested in. So first type of LOC is called associative. Okay. So this associative is an adjective. Okay. It describe the LOC. So what is associative? I think you have seen this before. So why do we need associative here? Let me tell you. So I have LOC, meaning I know how to combine two things. Imagine you want to combine three things together at the same time. How do you combine? If you want to combine three things together, how do you combine? What do you mean I combine one by one? Okay, so you can combine the first two first, right? There are two choices actually. So you can combine the first two first. Okay, then become one thing. And then you can combine with Z. Or what can you do? You can combine the last two first and combine with the first one. Why should I do this? Why should I do this? Because this star is a L or C. LOC says what? You only can take in two things at once. You only can take in two things at once. Okay, so you cannot do three together. But by right, these two are not necessarily the same. Not necessarily. Okay, when they are equal, it is called associative LOC. Okay, only when they are equal, you will get associative LOC. But so far, the max that you have done before are all associative. You don't need to worry about, right? Just multiply anywhere you like. Just add anywhere you like. Okay, so far is no problem. But go into further max, you will see non-associative LOC. Okay, but also very few were happening in this course. But yeah, but there exists something like that. Okay, so if it is true, okay, it is true for all. Okay, for all elements in the set. Okay, has to be true for all. Okay, cannot half true, half not true. Must be true for all. Does it make sense? Okay, only when it is true for all. Okay, I think it could be organized a bit. If this is true. Okay,
So associativity tells you how to multiply 3 things. 4 things, to tell you or not? How many possibility can do 4 things? Even more. Okay. But I want to assure you that if you try and list down all of them, you can use this associativity. If it is associativity, it will equal at any possibility that you do 4 things. Does it make sense? Okay. You can try and prove it. Okay. Does everyone understand what I'm trying to get? Okay. So if your LOC is associative, okay, try and list down all the possible way to multiply 4 things. Then you can see that they are all equal just using the fact that you know how to multiply 3 things together. Okay, try and work it out. Okay, try and work it out. It's a very good exercise. Okay, try and work it out. Okay, the last adjective I want to show you is called the commutative. Okay, commutative. Okay, so what is commutative? I think you are more familiar with this. If x star y equals to y star x, okay, you can commute. Okay, for example, 2 times 3 is equals to 3 times 2. Okay, so it commutes. Very important. So these are very important terminology we introduce. Okay, let's give some example before we break. Okay, after the example, then. For example, you want to give me some that you know? That is associative and commutative. Natural number, what can you do to it? Addition, okay, you can add them. So you can multiply them, right? Okay. It still stay inside the set. You need to check, okay, you need to check. What things you need to check? You need to check this. Okay. S cross S live inside X. Okay, later I will emphasize more later. Okay. What else? Any more example? Naturally, you go to integer law. Okay. You also can add, you also can multiply. Okay. And then also the number we introduced last time, very important example in our course, which is the modular arithmetic. Okay. Z mod n. This one we will talk in detail later. Okay, later I will talk in detail. Okay, I'll remind you how we add and multiply here. What else? Real number. Okay, if you like, you can do rational number also. Okay, what else? Matrices. Okay, matrices. You can add matrices. You can matrix multiply. Right or not? Linear algebra. Can see. Okay, matrices. What else? Last time we talked about function. Okay, function. Continuous function. If you compose continuous function together, you still get a continuous function. And later we will try and show whether they are commutative or associative. What? Any problem? Matrix multiplication is not commutative, is it? Yeah, it is not. Okay, so let me single this out. So we'll say that this is not commutative. But I think in the assignment, I asked you to prove that it is associative. Okay. I want you to get remind yourself what's the matrix language. Okay, for linear algebra. Even these is also not commutative. Correct or not? Can you give example or not? Give example or not? Continuous function is not commutative under composition. Okay, I'll let you think. Later we can discuss again. Okay, we will see this example and then try to show some of the property again. Okay, any question before we break? Any question before we break? So all the example I listed here is very important throughout this courses. Okay, we want to see numbers and then we want to put a lot of number together. Okay, and then we want to look for function. Okay, these are the few things we are interested in. Okay, set of function. Okay. Okay, please always keep this example in mind. Every property we want to discuss for them. Okay? So these will be our running examples. Okay, let's break until X06. X06.
最后那一堆不是灭霸是康，
什么？
蚁人最后那一堆不是灭霸是康。
什么？
我说你刚刚说蚁人最后那个不是一堆 Thanos，那是一堆康。
哦，是康哈。
对啊，不是。
yeah. 啊？Discipline of linear 啊，对，刚才你说 ODE 哦，啊，我没有 recall 啦，可是要给我那个 statement 呢。可是它是 unique，可能不 exist 还是这样子。对，哦，那个对你讲的那个对，那个system of linear，你那个 statement 是什么？把那个 statement 讲出来。还是它 unique 不一定 exist。unique 可是一定 exist 吗嘞？嗯，啊，对，什么意思？function apply on x 啊，是吧？给我想一下要怎样讲。没有，我们 consider 的是 function 罢了。比如说 f 跟 g，f compose g 是一个 function。我们不看它 evaluation 过后面的 image，我们看它 as a function。对，就是 f compose g 就是 f compose g 吧。当然，我们如果要 study 这个 function，我们还是要看它怎样 act 在 element 上面。等下可能我再讲一下，等下我们 show 那个 property，我们再 emphasize 一下。Yeah。Normally, usually 是 compose，usually 是 compose。如果乘的话，我们通常就写 FG 罢了。嗯，不会，我们会放 F 挂弧，G 挂弧 X 这样，记得吗？那个是 composition。FG 的话，FG 如果我只写 FG，通常 OK 这样子写啊，这样子。如果我们这样子的话，如果有看到这样的东西，可能这个就是这个。因为通常我们会写，因为可能我们以前没有考虑乘法，
所以因为我们这里可以考虑乘法，所以我们要把它分辨出。有时候我们放这个点呢，可能也很丑诶，最多放这个更丑哦，所以我就选择不放嘛。But anyway，就我们有这两个的差别在。Hello，你们要两个？那我先点你哦。你叫什么来着的？叫什么来着？莉迪亚？还不认识。
这个我
OK，Adrian，哦，莉迪亚，OK，good。Right, let's take some attendance. 潘小阳，OK. You were not here last time, is it? Are you still in calculus 2 or not? You still in? Okay. 林宏杰，OK. 陆子明，何俊彦。Is 何俊彦 friends of anyone or not? Does anyone know 何俊彦 or not? No. Okay. 曾子航，yeah. 嘉令，陆志炫，嘉令，Okay, good. T Sao okay. Yong Eugene, okay. Jasmine, oh, okay, hello. Hey, Jasmine, and what's Albert, right? So if you, both of you, if you, maybe sometimes I talk too fast in Chinese or what, or you want me to repeat English or what, you can do so. Okay or no? Okay. Do you guys really don't understand any Chinese or what? Little bit, little bit, you understand a little bit. You understand all or little bit? Sorry? Oh, you come here, you understand more. Yeah, but if I say any Chinese that you suspicious, you just ask me. Okay or no? Yeah, suspicious. Okay, Albert. Okay, good. 鲍成碧 Okay. 超金玉 Okay. 称浩瑞 Yeah. 称之浩。戴义成。Does anyone know 戴义成 or not? No, 戴义成 No. 何心怡，任秀彤，OK，yeah. 李冰霞，Anyone know 李冰霞? Okay, this three is always absent, no? Need to report maybe. 刘晓月，okay. 刘子涵，yeah. 对，yes. Is it 马玉轩，OK, sorry. 马宇轩，OK. 马宇轩，OK. 孙佳怡，yeah. 王芳瑜，王佳怡，yeah. 王舒瑶，吴雨一，yeah. 叶长宇，sorry 对啊，严胜，OK， 姚一晨，yeah， 一凡，到，OK， 钟一凡，OK， I must remember you too, 一凡 钟一凡， 周雪，OK， 康平， 拓新 Dao Seng, Dao Seng, Dao Seng, Hong Zhao Seng. Hong Zhao Seng was here last time, right? Anyone know Hong Zhao Seng? 请假，医院里咋了？他自己说的。OK， 希望没事。Q Man Chun， 昊天，金信，金信，一涵，修泽，修泽，微刷，微刷嘞 ，OK， 康信，康信 ，OK， 林恩，林恩 ，OK， 可是林恩，林恩 ，OK， 有 English name 吗？林恩 also 啦 ，OK， Ian OK， 曾苑，赵瑞，俊鹏，敬鹏 OK， 伟泽 OK。Anyone I haven't called yet? Anyone I haven't called? Are you enrolled here? Enroll? Is it? What's your ID again? Hey, sure. Hey, I'm not in the team chat. Is it? You want to add me? I mean, if you want to, if anyone want to tag me also. Want to ask something quick? Okay. Right. So I mean, whenever I put example like this, we need to show one. Okay, we need to show that it satisfies the definition. So there are a few things to show here, right? We need to show that whether this multiplication or addition or composition is the LLC or not. Is it a function of two variables? Okay, so you need to show. And are they associative or not? Okay, you need to check for every element. Okay, every element you need to check. Commutative also you need to check if it is. If it is not, if it is not commutative, what do you need to show? You need to learn because in exam you will be asked this kind of question. If you want to show something is not associative, what do you need to show? To show it is, you need to show for all, right? To show that it is not, give a counter example, right? Because for all negate meaning there exists. Okay, so commutative also for all negate, you have to show that there exists. Two things such that when they compose, they are not equal. Yeah, they are not equal. Very good. Okay, so I mean, some of them you really cannot show actually. It's by definition. Actually, some of them. Okay, for example, what? For example, natural number. Actually, we can't really show it. It's just how you define it. Okay, how many classes you have been in MA1? 2 classes, 1 classes, 2 classes. Okay, so far, where did you learn already? So have you guys done convergence? Have you guys done the completeness of real numbers or not? Finish already? Oh, so fast. Okay. Go very fast. Okay. So I mean, when I taught it differently. I start from okay, maybe I show you here. Show you from here. Okay, for now, you just listen, it's okay. I want to go through some history of number so that you have a context to know. That one is in MA1, actually, I did it. So I posted up my previous SEM MA1. So I suggest you to read at least, I think until completeness of real number, then will be same stuff with what you learned already. But before that, I recommend you to read my MA1 notes, because what I done there, I include what is logic, okay, all the truth table stuff, implication, you have to remember, because this is important for your proving. And then set theory, like just now, right? Show A and B are equal. This you have to brush it up again. Second, we build number from scratch. Okay, we don't just do real number. We start with natural number. Okay, so define a natural number. What you can do is you use P0 axiom. Anyone heard about P0 axiom or not? Okay, so yeah, good. So the P0 axiom here seems longer than the usual one. Okay, the usual one only have 5. Okay, here has 13, because some of them can be derived from the other. But for the sake of your study, so we list it more. Okay, so that you can see that what kind of property we can include here. For example, what let's screen through what property we include here. So first of all, in n here, in natural number here, we require that 1 is in there. Okay, we have to start from something. Okay, 1 have to be in there. Okay, in natural number. And then what else? We have few, for example, 2 to 5 here. We define what is equal in natural number. Okay, well, how to tell something is equal here. So if you quickly screen through, what did you see? X equal to X. X equal to Y implies Y equals to X. If X equals to Y and Y equals to X, then X equals to Z. What is this? Oh, transitive, reflexivity, and what else? Transitive, reflexivity. One more is what? Symmetry. So what's this mean? This equal sign is a equivalence relation. Okay, so whenever we talk about equal signs, we want equal signs to be like an equivalence relation. Okay, they have to be satisfied this property here. And then 6 to 8, I give a special function here called Sn. Okay, so if you look at axiom 6, for every n in this set, Sn is also in this set. Okay, but in the end, you will see that, where do you see? In axiom 10 here, actually this Sn is what? N plus 1. So meaning what? How we build 2, how we build 3, how we build 4, how we build 5. What is 2? 2 is 1 plus 1. Good. So this is by definition, not by calculation, by definition. 2 is 1 plus 1. 3, 2 plus 1. 1 plus 1 plus 1 plus 1 is another story already. Okay. So 4 is 3 plus 1, so on. So this is like what? Inductively define it. Okay. So actually you can prove mathematical induction from this axiom. Okay, mathematical induction. Lastly, 10, 11 is about addition, how you add. Okay, and then axiom 12 and 13, last two, is about how you multiply. Okay, then you will have these associative, commutative operation. Okay, this require proving. You need to prove. Theorem is a theorem. I didn't put this line inside my axiom. Did you notice? I didn't tell you. Okay, I just tell you how to add a number with some S number, but I didn't tell you it is associative. You need to prove one. Okay, so this is non-trivial, but we won't pursue this in this course. Just that I want to give you a context. If you're interested, you can study it. Okay, because this is what I test in my MA. They have to learn. Yeah, but it's not for extra algebra. Okay or not? But I just want to tell you where it came from. I think it's better for you to know. 不然你毕业了都不知道1、2、3怎样来的，不是很凄惨咩？ I graduate from degree of max, but I don't know what is 1, 2, 3. Right or not? Okay, yeah. So it's not trivial. It's a P0 axiom. Okay, coming from P0 axiom. So similarly, you can prove what do you prove? Distributivity law. Okay, and then commutativity law. All these require proof. How to prove? You need to use mathematical induction. Okay, you need to learn mathematical induction. So very useful mathematical induction in this case here. Okay. Okay. So even though you don't know how to prove these, I want you to know where they come from. Okay, this is what I want you to get. Where they come from. Okay, why they are commutative, why they are associative. So it is because of Peano axiom, okay, and mathematical induction. So this is the thing you need to remember. Okay, no need to know how to prove. Okay, in this course. So number here, how to progress? You have natural number, you have integer. Okay, natural number sit as a subset of integer, and then integer sit as a subset of rational number, and then so on. You can continue to real number. Okay. So how to define real number since you learned already? Let me not show you first. How to define rational number? How to define? Say again. Rational number. Oh, sorry. Real numbers. Sorry, I asked wrong question. Real numbers. How do you construct real numbers? Sorry, asked wrong question. What is real numbers? Real. 真的都是他们. What are real numbers? How to define real numbers? Oh, right. Okay, so there's one way to do it. You have your you define your rational number, you fill out rational number. But what does it mean by filling out rational number? Why you need to fill rational number? Rational number is a tom. Right. So how to fill? Yeah, of course use irrational number, but how to fill? 洞在哪里？要有洞才可以 fill 嘛，没有洞怎么 fill？ You need to be able to have a gap so that you can fill it in. So what gap is that? Why is there an irrational gap there? Why? This is a very serious problem, you know, at the time at Pythagoras. During Pythagoras time, 大家知道谁是 Pythagoras 吗？ Pythagoras theorem 知道吗？ S square 加 C B square 等于 C square. So Pythagoras time, they thought all numbers are just rational. Okay? You can use rational number to describe everything in this world. But it turns out it doesn't. For example, the ratio between what? The ratio between the circumference of a circle and the radius. For example, what? Square root 2. Did you guys learn square root 2 is irrational? How to prove it? Very important proof, huh? You know why? There's one guy, tell this Pythagoras, not Pythagoras itself, it's the cup. 追随本 Pythagoras 的人 tell them, no, this world exists an irrational number other than rational number. You know what happened? Got killed. Kill 美啊 irrational 不美啊写不出来啊写不完啊 correct or not? Decimal expansion never ending for irrational. It's not repeating also. You know, 讲真相还被人家杀掉。So be careful when you want to talk about truth. So what? You need to prove to people why is it irrational. Okay, why something is not rational. Okay, so did you guys learn irrational as a limit of Cauchy sequence of rational number? Did you guys learn that? No. So how do you learn completeness? I'm curious. Why is it complete? What's the definition of complete? No empty subset then has a least upper bound. Oh, okay. Yeah. So every non-empty subset has a least upper bound. So I mean, then if you use this way to approach a real number, right? Can you write square root 2 as a least upper bound of some set or not? You need to ask yourself, or ask your Li Peng. Otherwise, doesn't make sense. Why learn all this? 不用学啊，不知道啊，为什么啊？对不对？So the main problem here is this, that exists a set
with a least upper bound irrational GG 啊，right 吗？不用紧啊，没有就没有了，我加进去。Yeah, this is how we construct real number. Okay, as a least upper bound of a non-empty set. Okay. Another construction we can use is a limit of Cauchy sequence of rational. This is the second one. Okay. Have you learned Cauchy sequence yet? Not yet. Not yet. I think after conversion, you guys should learn Cauchy sequence. Okay. Okay, I don't want to tell more about that one. I'm not teaching MA here. Okay. Next time we can talk about it. So let me summarize for you. Summarize for you. What is real number? So real number are a set that satisfy these three things: field axiom, order axiom, and completeness axiom. Okay, completeness axiom is what you learn. Every non-empty subset have a least upper bound. Okay, this is what you learn. And more importantly is this field axiom and order axiom. Okay, so what does this field axiom do? Tells you how to add law, how to multiply law. This addition and multiplication is associative or commutativity. So this is by define, no need to prove one. You should be happy. 不用 prove 的东西应该要开心 but you have to learn the definition. Okay. What other than these, you need to have identity law, inverse. Later we will talk about this. Okay, in a general group. Distributivity. Okay, so these are field axiom. Okay, we will see field again in future. So first of all, R is a field. Look at here. Excuse me. First of all, R is a field. Okay. Second of all, okay, from field, we can deduce all these property. This all property is what you learn in your high school. 减减变加，为什么？证明。OK 了吗？还有什么要证明 ？Inverse, go back， 证明。Only using field axiom, using field axiom, we can deduce all these. If you are interested, you can look at my MA1. Okay, all this you learn, whatever you learn in primary school, you use in primary school, high school, need to prove one. Okay, from field axiom, not for free. Next, order. 为什么1大于0？要证明，你知道吗？要证明的，为什么1大于0 ？Okay, so order. The most important thing about order is this trichotomy law. Okay, if you want to get a summary of this, trichotomy law is the most important one. What is trichotomy law? One number only have one condition can satisfy. Okay, so if you compare two numbers, there's only one condition you can satisfy. Either one is greater than the other, either they are equal. 就3种情况罢了。OK。比如说1小于0 1等于0跟1大于0，就一个情况会对吧？多过一个情况对就完蛋了，这个 system。Okay? Okay, so from this trichotomy law, you can prove that 1 greater than 0. Okay? All the other you can see that it's like, what is this? Like pole set. Pole set. Partial order set. Partial order relation. Relation. Forgot how to call it. But anyway, yeah, so we can prove 1 greater than 0, for example. Once we prove 1 greater than 0, you can prove 1 equal 1. 1 plus 1 is not 0. So it makes sense to define new things for 1 plus 1. Okay, very rigorous. This is what we did. Okay, very rigorous. Okay, need to check everything what we say is true. And then, for example, this inequality law that you use, if you divide by something negative, you need to swap sign or swap the what's that? Swap the inequality, correct? All these require proof. From this axiom, you can prove it. Okay, this is what I want to show you. And then this is the next one is the completeness axiom that you know. Every non-empty subset of real number which is bounded above has a least upper bound. Okay, need to be bounded above first, not just random subset. So sometimes we also call it as a least upper bound axiom. Okay, so these three things together make up our real numbers, and then you can show that anything that satisfies these three set of axiom
They are the same. Okay, same up to some equivalence. They are the same. So in this world, there's really only one type of real number. Okay, maybe the one you write down is one type. Maybe you can have other way to write it out using alien language. But if they satisfy these three things, they have to be the same. So this is the associative commutative of number system. We define one. Okay, no need to prove. But other than that, for matrices, for function, those associativity and commutativity were built on this thing that we know. So meaning what? So after I say all these, do you know what you can use now? What can you use in your working or your assignment? You can use the fact that numbers are associative and commutative. Okay, so I speak long story here. This is what I want to convey to you. These things are what you don't need to prove. You can use it. But if you are interested, you got extra time, then you go to the note I posted in the Moodle. Yeah, for my email. Okay, so let's see some example 讲多也是没有用，做一点 example. See which one we can do first. Let me see. Which one should we do? Okay, let's do this one. Okay, let's do this one. So just now, Adrian say was confused by this function stuff, right? So let's try and prove that the continuous function from R to R with this composition is associative. Okay, associative. So what's the element inside here? What are the elements? How does the element looks like inside here? So to prove this statement, right, you need to ask yourself, how does this set looks like? 这里面的东西长怎样？ what is this set? Set of what? Inside here, set of what? 什么东西在里面？ And recall the definition or not? There's quite a few notation in this class. I admit a bit confusing. There's a lot of notation you need to remember because too many words we want to save our time. So what's this definition? What kind of function do I consider here? Limit? No. What kind of function? Yes, continuous. Okay, continuous function. Remember what I talked about this C0 story? We can put C1, C2, C3, C4. What does it mean? C1, C0 mean continuous. C1 means what? Differentiable. C2 twice differentiable. Okay. So continuous function from R to R. Okay, like that. So the element here looks like what? Just function. For example, F1, G1, G2, like that. Okay. It's not Fx. Fx live in where? Fx. So, okay. Please don't confuse with this Fx. This Fx means what? F apply on X. Already evaluated. So where should it lies? In this case, for example, image of X, which is not function anymore. Okay, function is a thing that take input and tell you the output. Okay. Okay. So if we want to show associativity, what do we need to do? Remember, when we want to write down the proof, how should we write first? Write the goal first. Okay, 目标要清楚. Okay, want to show for every 3 function inside my set. What do I need to show? Let me check. What do we need to show? I want to show associativity, right? So what do I need to show about these three things? What I need to check? Sorry? Yeah? What do we need to check? What's the equality I need to check? Huh? F compose G bracket compose H equals to F compose G bracket G compose H. Okay? But how to show two functions is the same? How to show two functions is the same? How to show function is the same? Cannot. If we don't evaluate, we cannot. We need to evaluate. They have to be same at all points. Okay, so we need to evaluate it. So meaning what? So meaning to show that function is the same, we need to show that for every x in our domain, both sides evaluate to the same number. Okay or not? This one so you see 看得到吗？大家有两个等于不一样的等于在这里看得到吗？都是两条杠，但是不一样。哦，这两个等于不一样Understand or not? You see this equal sign here, what's the object beside it? Function. So this is equal as function. But I tell you, to show that equal as function, what do you need to do? You need to evaluate at every point. Okay. So after you evaluate at every point, what is the left-hand side, right-hand side here? Something in your core domain. In this case is R. So this equal sign, you know or not? You know about this equal signs here? You know, right? Just ask you whether two number is the same or not. Okay. Okay. Okay, so here is equal as real number. Yeah, it's number. That's real number. So how is it a number actually? You should ask it. So before that, you need to ask yourself, how do we define f compose g as a function? If f is a function, g is a function, why f compose g is a function? To be a function, what f compose g has to do? Okay? Map, okay? So meaning what? If I give you an input, you need to give me an output. So let's say define this as a function. So how do we define this? To show this, we need to know how do we define this. So how do we define this? So for every x in your domain, how do we define f compose g as x? Do you have any idea? How do we define this? How do we define? How do we define? How do we define? Any idea? F is a function, G is a function, both of them can take input, So we can do gx first, become a real number. I can fit it to f again. Is also a real number. Okay. So meaning what? Meaning what does this function do? If I fit x to it, I first fit the x to g, and then I fit gx to f. Then the end result here is what? Define f compose g acting on x. Okay. Does it make sense? Okay. Right. So this is a function. So how do we define the binary operation here? So So we want to verify that. Verify what? Verify that this is a verify that this is a LOC. Okay. Okay. So to prove that, wow, this LOC is associative, first you need to start with LOC. If it's not LOC, no need to prove anymore. 题目不成立的，可以丢了这个题目。So you need to check first, are you starting with a LOC or not? Only then you can continue with associativity. Correct or not? Because why? We only define associativity on LOC, not other stuff. LOB, I don't know what is associative LOB. LOD also don't know. LOZ also don't know. Must be LOC. Okay or not? So we need to prove that. Why is this defining an LOC? Okay. So verify that this is an LOC. So how do we define this map here? So this composition map, what do? We take two functions here. So for O, F, and G, the continuous function from R to R. What do? We simply output what? F compose G. Right now. So this circle here is an operation that it two function become a function. Okay, I already show you that it is function. But to be a LOC, what else do you need? It has to stay inside the original set. To stay inside this original set, what do you need to satisfy? What is this set? Tell me, what's this set? Set of continuous function. I proved to you it's a function already. But is it continuous? Continuous. Continuous or not? Okay, actually this one need a MA proof if you want to use epsilon delta. But in calculus 1, you already learned composition, but okay, let me put here, but in cal 1, we know that composition of continuous function is still continuous. Okay. So please, after you learn your MA1 epsilon delta and continuous, try and prove, is a composition of continuous function continuous or not? Try and prove yourself. Okay, you need epsilon delta definition. Okay. I cannot do it here now. Okay, but I think this is what you're being taught, right? You have been using this all the time actually, if you are using it. Okay, so you need to remember this fact here. Composition of continuous function is continuous. Okay, so I make a remark here. Proof in MA1. Okay, after you learn continuous function, okay, you should do this proof here. Yeah. Okay, so we leave this continuity to MA1. Right. So we know that it's LOC already. Now is the time to check associativity. Okay. So associativity, what do? We have left-hand side and right-hand side, right? We can try and one way to see is we can compute both sides and then see whether they give the same number or not. Okay. So let's write down what is left-hand side. Let's write down what is right-hand side. Okay. Left-hand side is what? F compose G compose H acting on X. Okay, so for OX in R in your domain. On the other side, what do we have? We have composing G and H together first, and then we compose with H. Okay. Okay, so for the first line, what's the first equality you get? By definition, what do you get?
check the definition again. Well, how do we define this circle thing? We know how to do on two function first. So the two function here is f compose g and h. Okay, so which one we do first? H first or h compose g first? Okay, so this is by convention. We will do h first. Okay, some people will read from left to right. We read from right to left. Okay, so this is just convention. Okay, different people will have different convention because in some of the calculation, maybe left to right is easier to see. Okay, but for our case, we go from right to left. Okay, from right to left. This is by convention. Define one. We pick this convention. Okay, does it make sense? Okay, all right. So then, how about this? Can we continue apply the definition or not? Can we? Hash is a number already, right? So you evaluate f compose g on a number. Use the definition again. No? What do you get? F apply on g hash x. So what does this mean? Conjugal bracket has been. What does this mean? Hs is a number. G acting on number, you get a number. F acting on number, you get a number. So it's a number only. Okay. Next, how about this case here? How about this case? How about right hand side? What's the first answer you get? First line. F apply on G compose H bracket apply on X. But what is this inside here? G on HX. So you can see that both of them compute to the same thing. But what happened is the order we apply the function is different. That's all. But at the end is the same. Okay? Same or not? Does everyone agree it's the same? Is F apply on G apply on HX? All of them. Both of them is equal. But the middle here is interesting. We go through a different path. We go through a different path. Okay? But it's okay. We get the same answer. It's okay. Okay, so since left hand side equals to right hand side, we see that what? The continuous function is associative. Okay, associative. Okay, right. Okay, let's go to one example. Just now I asked you. So determine. Okay, about just right here. True or false? Okay. So ask you whether the function composition is commutative or not. I let you think about 2 minutes. Try and discuss with your friend if you can come up with an answer. Try and introduce yourself to the one beside you, because the one beside you is very important for your assignment. You need to ask them, discuss with them. Get some friend. Get some friend in this class. Get some help. Okay, give you 2 minutes. Think about this question. True or false? True, prove it. False, give me counter example.
Okay. Any idea or not? True or false? Huh? False. True? False. False. So if you say false, you need to give me counter example. So what's the counter example? What f, what g I can take? What two function I can take? Huh? No, you need to give me f and g first, right? No need to tell me compositing first. What f you can take? One. Constant function, huh? We try, lor. Yeah, let's try. Take fx equal to 1. G, leh? G, leh? X, ah? Okay, let's try. Let's try. Let's try. So I like to try. Why, tomorrow? Tomorrow. Only. Doesn't work, huh? Why doesn't work, eh? Fg is what? Fg is what? X is it? Let me think. Wait. Okay, so first of all, these two are continuous function or not? Very good continuous function, right? Constant function and the identity function. But what is fgx? Gx you get x, fx you get 1. Okay. Or maybe I don't jump step. Okay, so what is this x for every x in R, obviously? How about the other case, gfx? Fx is what? 1a. 1 is still 1, huh? Not very good, huh? So how? So should I change my answer to true or not? Why no, leh? What you still believe there's a counterexample? You believe, You believe? Right? Give me one. Give me one. I can tell you, this kind of question, true or false, give counterexample. The counterexample won't be hard to find one. Okay, should be some very easy one. Just you need to change a little bit. Okay, so this one won't work. So let's change the other one. Change a little bit, lor. Can you change a little bit? 已经没有 continuous function 的 example 了。x square 减 x， 哇哦，去了一个很远的地方。It's okay, that's fine. Next, you want to keep x or not? Or change? Check what? X. Can? Let's try. So let's see. So what is fgx? So we do gx first. What do we get for gx? We get f2x. And then f2x is what? 2x whole thing squared plus 2x, which is what? 4x squared plus 2x. Okay, how about the other direction? Gfx, right? Okay, so what is fx? So x squared plus x. So but g of this thing is what? 2 times the whole thing, which is what? Equals to 2x squared plus 2x, which is not equals to 4x squared plus 2x. Yeah, good. Yeah, good. Okay, yeah. But to be precise, how to see these two are not the same? You need to evaluate on the same number, but they give the different number. For example, what? If I put x equals to 1, what do you get here? 4. And then here, like 6. On the point, on one point, they are different. They are not the same function already. Good or not? Only need to check one point. If you have to check for equality, you need to check for all points. Okay, very good. Okay, any questions so far? No? I think time's up. we'll see you on what day? Thursday. Yeah, if I got any news on class replacement, I'll let you know. Okay. Thank you.